Oh, hello. These are the solutions to the impulse and momentum worksheet. So we're going to dive right in. What is momentum? Well, momentum is mass in motion. The way that we find momentum, we use a P for it. Momentum is equal to mass times velocity. When Isaac Newton said an object in motion will remain in motion, what he meant by motion was something closer to momentum than it was velocity. It is impossible to have something moving that doesn't have mass while we're talking about regular physics stuff. So, motion, an object in motion, is going to have momentum. That's just how it works. No motion, no momentum. No mass, no motion. What's the unit for momentum? All right, well, the momentum is mass times velocity. So mass is measured in kilograms, velocity is meters per second. So our unit for momentum is kilogram meters per second. And yes, momentum does have a direction. It's a vector. And the direction is the same as the velocity. All right, what is impulse? Impulse is a force applied over a time. We use a J for impulse, and impulse is force times time. The units for impulse, looking at force, we have newtons, and time is seconds, so impulse is newtons times seconds. And then impulse and momentum are the same thing. They are interchangeable quantities. If you apply a force over time, you're going to change the momentum of an object. So impulse and the change in momentum are the same. So an object is moving and has some momentum. Oh, wait, sorry. So impulse J is equal to change in momentum. So I've got an object that's moving. It's got some momentum P. If I double the mass of the object, P is equal to mv. So if I double m, I'm going to double the momentum. So we have twice the momentum. If I double the velocity, same thing. Momentum is mv. If I double the velocity, I double the momentum. And if I stop the object, the momentum is going to be 0. Because if I have no velocity, I have no momentum. And then if the object reverses direction, so it's m times v, but it's moving in the negative direction, it's going to be negative p. It's just negative momentum. Direction is important. So, let's say you were tossed off the side of the building. Would you rather land on cement or a trampoline? You would rather land on a trampoline because the time of the collision is extended. We get longer time when we hit the trampoline. It's stretchy, it's bouncy. We don't stop right away when we hit it. So the impulse will be the same as if we hit the concrete. So impulse really isn't a factor. You're going from moving to stopping. So in either case, you have the same impulse. But on the trampoline, you have a longer time for the collision. So the force on this object is reduced. It gets smaller because of that. Sorry, and that's why you want to land on the trampoline. It has less force. It's better for you. All right, now we've got some number problems. So we're going to look at this and we're going to identify all of our givens. The average baseball has a mass of 0.25 kilograms. Well, that's the mass. It's 0.25 kilograms. A pitcher throws the ball towards the batter with a velocity of 40 meters per second. So the initial velocity is 40 meters per second. And the batter hits it back to the pitcher. That's a reverse in direction, so we get that negative sign there of negative 60 meters per second. So that final velocity is negative 60 meters per second. Those are all the things that we know. A wants to know the momentum of the baseball before it's hit by the batter. That's my initial momentum. My initial momentum is mass times the initial velocity. So we have 0.25 kilograms times the initial velocity of 40 meters per second. The initial momentum is 10 kilogram meters per second. The momentum of the baseball after it's hit by the batter, let's see if we can leave those known, the givens there. Right, after it's hit by the batter, it tells me we're going to find the final momentum. That's mass times the final velocity. So we have 0.25 kilograms times the final velocity of negative 60 meters per second. The final momentum comes out to be negative 15 kilogram meters per second. That negative sign makes sense because we're now moving in the opposite direction. If we have opposite direction, we're going to need to have opposite sign. And then the impulse on the baseball, well, impulse is the change in momentum, so it's final momentum minus initial momentum. So my impulse is negative 15 kilogram meters per second minus 10 kilogram meters per second. Negative 15 minus 10 gives me an impulse of minus 25 kilogram meters per second. And if this collision took place in 2 times 10 to the negative third seconds, I want to know the force exerted on the baseball. First things first, force times time is the impulse. But I got to figure out the time because I don't want to use scientific notation. So if I've got 2 times 10 to the negative 3, what I'm going to do is take my decimal place that's at the right side of 2, and I'm going to move it over 3 spots to the left. So I go 1, 2, 3. That's where my new decimal place goes. So that time is 0.002 seconds. That's my time. So we're going to have force, which we don't know, times time, 0.002 seconds, is equal to impulse, negative 25 kilogram meters per second. So we'll divide both sides by 0.002. And that gives me a force of negative 12,500 newtons. 6, we're going to go through the givens again. We have a car of mass 450 kilograms. So my first known is mass, 450 kilograms. There's an initial speed, so initial velocity of 35 meters per second, and accelerates to a final speed of 45 meters per second. And all of that takes a time of 10 seconds. Those are the givens, those are the information I know. We've got to figure out how to use it. If I want the initial momentum of the car, initial momentum is mass times initial velocity. 450 kilograms times the initial velocity of 35 meters per second, giving me an initial momentum of 15,750 kilogram meters per second. The final momentum of the car, make sure we can see our knowns here. Final momentum of the car, P final, is going to be the mass times the final velocity. So 450 kilograms times the final velocity of 45 meters per second. That gives me a final momentum of 20,250 kilogram meters per second. So now I have my initial and final momentums. I want the change in momentum of the car. Well, change in momentum is final momentum minus initial momentum. So 20,250 minus 15,750. Put those, subtract those, and I end up with a change in momentum of 4,500 kilograms. From here, if I want the force, that force times time is equal to impulse, and I also know impulse is equal to the change in momentum, so I can substitute for impulse, and I get force times time is equal to the change in momentum. Well, I want to know the force. I know the time is 10 seconds, so force times 10 seconds is equal to the change in momentum, 4,500 kilogram meters per second that we just found. Divide both sides by 10 seconds, and we end up with a force of 450 kilogram meters per second squared, which is 450 newtons. A car of mass 300 kilograms traveling north with a speed of 25 meters per second. So I am given that my mass is 300 kilograms. I am given that my initial speed is 25 meters per second. We kind of need to keep in the back of our head that that's going to be to the north. So if I want to find the momentum of the car, mass times velocity, so 300 kilograms times 25 meters per second gives me a momentum of 7,500 kilogram meters per second. There we go. There's our momentum. Now, an impulse of 10,500 kilogram meters per second south, so that's in the opposite direction, that's going to be important, is applied to the car. Calculate the new momentum. So before we begin, we got to figure out that impulse, right? So that impulse is 10,500 kilogram meters per second. But it is opposite the direction, or it's opposite the momentum of the car. That momentum, 7,500 kilogram meters per second, is north. Right? This net impulse is south. So it's going to have to be negative. So the impulse is negative. So it's negative 10,500 kilogram meters per second. So the impulse is also equal to the change in momentum. So the impulse is equal to the final momentum minus the initial momentum. So negative 10,500 is equal to the final momentum minus the initial momentum, 7,500. We're going to add 7,500 to both sides. And my final momentum comes out to be negative 3,000 kilograms. Now I want the new velocity of the car. Sorry, kilogram meters per second. For the new velocity of the car, well, I know that final momentum is equal to mass times final velocity. So negative 3,000 is equal to 300 VF. Divide both sides by 300. And my final velocity comes out to be negative 10 meters per second. And again, that negative sign just means we're going in the opposite direction that we started from. All right, next question. Last question. 4 kilogram object has an initial velocity of 14 meters per second. So I got two pieces from that sentence. My mass is 4 kilograms. My initial velocity is 14 meters per second. A net force of negative 4 newtons. So my net force is negative 4 newtons. Acts on the object for a time of 5 seconds. Those are all of my knowns. And I want the new velocity of the object. So here's how this is going to work. I've got force and time and mass and velocity. So we know that we're dealing with impulse and momentum. So impulse, force times time is equal to impulse. Impulse is also equal to the change in momentum. So force times time is equal to the change in momentum. But I know that the change in momentum is final momentum minus initial momentum. So I'm going to substitute that in there. And I know for each momentum, it's mass times velocity. So force times time is mass times final velocity minus mass times initial velocity. So we can plug in our numbers now. Negative 4 newtons, that's my force, times 5 seconds, that's my time, is equal to 4 newtons times the final velocity, 4 kilograms minus the final velocity, times 4 kilograms, minus 4 kilograms times the initial velocity. So I get negative 20 is equal to 4 V final minus 56. So we're going to add 56 to both sides. All right, they cross out on the right, and that leaves me with positive 36 is equal to 4 times V final. We'll divide both sides by 4, and V final comes out to 9 meters per second.